Okay, last recursive algorithm before we finish our discussion of recursion, at least for this lecture. Binary search, one of the most basic recursive algorithms. Let's say you have a sorted array of n numbers and a particular number you're interested in, x. Is this number x in the array? And so what do? We do simply look at the sorted array 1, 2, 4, 8, 6, 10. And we look, and since we know it's sorted, and let's say x is 7, since we know it's 7, we look in the middle of the array. We see, okay, if, and let's put the divider here. We see, okay, since the middle has value 8, then if 7 exists in the array, it must be on the left half of the array. If since otherwise, if x was larger than this middle, then it must be in the right half. Okay, so this function is written like so. We calculate a particular middle value, and if x is the actual middle, then we return yes, it does exist in the array. Otherwise, we look either in the left half of the array or the right half of the array. So how fast is this algorithm? That's what we want to know. How fast is this algorithm? Well, we could describe it very, very easily, right? We could say that O of 1 running time, we only do one bit of work here, which is simply this comparison. This comparison right here is the only work that's completed. And then we know that we have one recursive call, which is simply either this function or this function, but not both, right? Just because you see a function twice just because you see a recursive call twice in a function doesn't mean both recursive calls are going to be taken. And in fact, in binary search, always one recursive call is taken or the other. Okay, so what does the recursion tree of this recurrence look like? Well, that's right here. Well, we got something that takes n, and then it goes to n over 2, then it goes to n over 4, then the input is n over 8. But what we know is that at each level, there's one work, there's one work, there's one work, and there are log n levels. So of course, 1 times log n, 1 times log n, oops. Okay, there we go. 1 times log n is of course O to the log n. And that's the running time of binary search. And we will be discussing many, many different binary search problems in Lab 9. So stay tuned for that. All right, I'll talk to you guys again soon.